So good morning to everyone. Erode Sengunthar Engineering College, Tamil Nadu presents under AICTE PRERANA scheme for preparing SC/ST students for higher education GATE. So I am R. Krishnasamy, Assistant Professor, Civil Engineering Department, Erode Sengunthar Engineering College, Tamil Nadu. So today we are going to see the topic of fluid properties and fluid statics in the subject fluid mechanics and machineries. So let's discuss about what is fluid properties and what is fluid statics. So for the syllabus for included in the fluid properties and fluid statics are dimensions and units. Then list the fluid properties such as density, specific weight, specific volume, specific gravity, viscosity, compressibility, vapor pressure, capillarity, and surface tension. Whereas we're coming to the fluid statics topics, we are going to discuss about definition of fluid statics and what is meant by hydrostatics law, then Pascal's law. So what are the different pressures, that is atmospheric pressure, absolute pressure, gauge pressure, then vacuum pressure. Then come to the measurement point of view, measurement of pressure by various types of manometer, that is simple manometer, U-tube manometer, differential manometer. So likewise we are going to discuss then what is that buoyancy and meta center. So let's start with what is meant by fluids. So it's everyone knows that fluid is a substance which has a no definite shape and will continuously deform or flow whenever an external force is applied to it. For example, water is one of the best example for fluids, then milk, steam, gas, etc. So it cannot preserve its shapes unless it is restricted into a particular form, depending upon the shapes shape of the surroundings. So let's discuss about what are the different types of fluids in our fluid mechanics. That is ideal fluid, real fluid, Newtonian fluids, non-Newtonian fluids, ideal plastic fluids. So what is that ideal fluids? So ideal fluids is one which has no property other than density. So such fluids have no viscosity, no surface tension, or incompressible. So when such fluid flows, no resistance is encountered. Ideal fluids is imaginary fluids, as all the fluids have some viscosity. So other than ideal fluid, let's discuss about what is meant by real fluids. So in the name itself, we can see the fluids. The fluid which have a viscosity, surface tension, in addition to density. So all the fluids have these properties, whether large or small. So Newtonian fluids is nothing but fluids which follows viscosity, surface tension in addition to density. So all the fluids have, so Newtonian fluids is nothing but which follows Newton law of viscosity, or called Newtonian fluid. For example, water, kerosene, air, etc. We call it as a Newtonian fluids. Whereas non-Newtonian fluids, it does not obey the Newton laws of viscosity. So example is slurries, mud flows, polymer solutions, blood, etc. An ideal plastic fluids, a fluid in which shear stress is more than the yield value, and shear stress is proportional to the rate of shear strain. So let's discuss about classification of mechanics in a very simple manner. So mechanics is we have three classifications: rigid bodies, deformable bodies, then fluids. So we in your syllabus you have discussed about engineering mechanics subject. Those all the subject we call as rigid bodies. Whereas in your subject solid mechanics you're going to study about the what is meant by deformable bodies. Whereas come to the fluids, we are going to discuss about the fluid mechanics. So in that case, we are having a fluid statics and fluid dynamics. So dynamics having a further two classifications: fluid kinematics and kinetics. So far we have discussed about what is meant by fluids. Now we will go for a what is meant by fluid mechanics. So it's a study of fluids either in motion or at rest. If we are study in motion, we call this a fluid kinematics and fluid dynamics. Whereas if we are study at rest position, we call this a fluid statics. So gases and liquids, example air and water, comes under the category of the fluid. So why we need to study the fluid mechanics? Is it essential for the all the engineering degrees? Yes, if it is, if anyone, if you want to become a fluid engineer or any electrical engineer, they have to become a. We need to study about the fluids, how he becomes, how it mechanics is works. Everything we have to study. Then only we can predict the applications. Fluid mechanics is one of the basic courses in engineering. It is a bridge course between what you already studied in physics and the core B courses which you will be studying after first year of your degree program. So what are the examples applications? Field exam applications are milk industry, water industry, air, refrigerant, steam. So everything uh, we need to study the fluid mechanics. So for the design of water supply, treatment, pumps, ships, storage tanks, piping systems, then measurement instruments, then cleaning department and the heat transfer behavior. So all the phases we need to study about the fluid mechanics applications. So we need to know the what are the basic units and what are the basic dimensions going to use in the fluid mechanics. So units already know that unit is a measurement, is a definite magnitude of a physical quantity. So it have a different systems. So one different system which follows in the different countries, whereas SI is the standard universal system, that is international system of units, whereas CGS is nothing but the centimeter grams second systems, whereas MK system, it is a metric system of physical units based on meter as the unit length, kilogram as a unit of mass, second as a unit of time. FPS, foot pound second system or FPS system, is a system of units built on the three fundamental units: foot for length, pound for either mass or force, second for time. So some of the units and dimensions we are listed here. So quantity is mass and kilogram, whereas unit is we mentioned in kg. So length in meter, unit is we mentioned as a m. So time in seconds we mentioned as a s or SEC. Then temperature in Kelvin, we unit mentioned as a K. Then mole we mentioned as a G MOL or simply as MOL. So force we consider as a unit as Newton, that is simply we call it as a N. Then pressure in Pascal we mentioned as a Newton per meter square. Then work or energy in joule, so we mentioned as a J. So power in watt we mentioned as a W. So these are the commonly used by used in CGS, MKS, FPS, and SI systems. So length is mass. So length, mass, time, force for the CGS system, for the MKS system, FPS system, SI units. So in case if it is the mentioned in terms of prefixes, what we call is a 10 to the power 9 means we mentioned as a giga, 10 to the power 6 we mentioned as a mega, 10 to the power 3 we mentioned as a kilo, 10 to the power minus 2 we mentioned as a centi, 10 to the power minus 3 we mentioned as a milli, so 10 to the power minus 6 we mentioned as a micro, 10 to the power minus 9 we mentioned as a nano. So these are the respective symbols, kindly go through it, which is used in the your gate preparations. So these are the dimension which we frequently use in the fluid mechanics. Length we mentioned as a dimension as a L. Time is which is mentioned as a T. Mass we mentioned as a M. Sometimes we call it as a MLT systems. For the dimensions analysis, we will discuss in the further classes for the gate preparations. So simply go through it. And also MLT is the primary quantities. So remaining term everything we mentioned as a derived quantities. whereas wall area is L square, which is derived from primary quantities length into length. Volume we mentioned as a L power 3, that is L into L into L. So which is the three factors, three quantities derived from primary quantities. So likewise, all the quantities we mentioned in dimensions, which is derived from the basic MLT systems. So these are some of the unit conversions which have to be known for the objective type presence. Then only we can easily solve any problem asking in your gate exams, which will be used to easily convert the unit conversions into the basic MLT systems. So 1 to 3.28 feet, 1 meter equal to 1 feet equal to 12 inch. So 1 inch equal to 2.54 centimeter, 1 kilometer equal to 0.621 miles. So these are the basic properties which is studying for the fluids. So what are those? First one is density, second one is specific weight, third one is specific volume, fourth one is specific gravity, fifth one viscosity, compressibility, vapor pressure, capillarity, surface tension. So once again I'm listing the fluid properties: density, specific weight, specific volume, specific gravity, viscosity, compressibility, vapor pressure, capillarity, and surface tension. So density is nothing but the mass. So mass of fluid per unit of its volume is called mass density. So we are considering 1 meter, 1 meter, 1 meter, 1 meter length, 1 meter width, 1 meter height. How much mass is occupied for the 1 meter cube? So that fluids we called as a mass of fluids. So density of water, we basic standard density of water is which is equal to 1000 kg per meter cube. So 1000 kg of water which is occupied in a 1 m cube of volume. So that is the definition for that. So we simply mention density as rho. Here notation is mentioned here rho. So I highlighting the term. So rho is the density of then formula is mass per volume. So note down. So mass per volume. So unit is kg per m cube. So dimension is mass we mentioned as a m. Volume we mentioned as a volume is a L cube. That is m divided by L cube. So which is bringing to the numerator. So m L power minus 3. Whereas in terms of we mentioned as a weight density, so nothing but simply we converting kg in terms of Newton by the multiplication of 9.81. So weight of fluid per unit of its volume is called weight density. So we are multiplying 9.81 into 1000. So which is converting Newton per meter square, meter cube. So formula is nothing but weight of fluid divided by volume. So whereas mass density we mentioned as a mass by volume, whereas here weight by volume. Simply we are multiplying in terms of G, acceleration due to gravity 9.81. Then another fluid properties is specific volume. This is the inversely proportional to the mass density. That is volume of substance per unit of its mass is called specific volume. Whereas density we considering how much mass occupied for the 1 m cube of volume. Whereas here how much volume which is occupied in 1 1 kg of mass. So that is a definition for specific volume. So V is equal to 1 by rho, that is equal to volume by mass. So unit is so vice versa. So m cube by kg. So dimension m power minus 1 L power 3. So next specific gravity. So specific gravity ratio of density of a substance to the density of fluids, standard fluids is called specific gravity. So in mathematical relation we mentioned as a density of substance divided by density of water at 4 degrees Celsius. So dimension is constant. So it is a dimensional quantity. So for us, we simply mentioned as a constant value only. So let's see the some frequent problem or important problem which is asking frequently in gate preparation exam like that where they asking if it is the calculate the specific weight, density and specific gravity of 1 liter of liquid which weighs 7 Newton. Simply they given as a two datas. Number one, 1 liter of liquid is given, that is 1 liter is the given datas. Another one is weight is given 7 Newton. So what are the parameters they asking for? Specific volume, density, then specific gravity. So as we have discussed previously, the formula is specific weight is weight by volume. Simply they provide the weight is 7 Newton. So unit for weight is specific weight is Newton per meter square only. So simply we are directly substitute the 7 Newton value in weight. Then volume, here volume they given as a 1 liter. So we have to convert liter in terms of meter cube. For us, 1000 m cube which is equal 1000 liter which is equal to 1 m cube. Whereas here they provide as a 1 liter. So simply converting in terms of meter 1 divided by 1000. So put it as a 1 by 1000 in the volume denominator. So it's a denominator. So bring it to the numerator. So 7 into 1000, 7000. So 7000 Newton per m cube. Let's come to the second one, density. So density is nothing but the so converting from density to specific weight, we simply multiply by 9.81. Whereas we are converting from specific weight to density. So simply divided by 9.81 by so our weight specific weight is 7000 Newton per m cube. We are converting, so that's why we are simply multiply divided by 9.81. So 7000 divided by 9.81, which is equal to 713.5 kg per meter cube. 713.5 kg per meter cube. So third parameter, specific gravity. So specific gravity, what are the data we need to know? First one is density of liquid we have to found. Then density of water is standard one. So simply density of liquid, what we have found out for the density of the our liquid is 713.5. So divided by density of water, standard density of water value is 1000 kg per m cube. So simply put it in the denominator. So 713.5 divided by 1000, which is equal to 0.7135. So this is the specific gravity of our given problem. So the answer finally specific weight is 7000 Newton per m cube, density is 713.5 kg per m cube, specific gravity 0.7135. So this kind of problem you can frequently experted from gate exams for simple terms. So likewise we can expect more number of problems we will solve in the further classes. So this is the list of assignment which will you yourself solve it yourself, and also you have to prepare it for your gate preparations. So number one, list of the application and industries of fluid mechanics. Write at least 5 units and dimension units used in fluid mechanics. Then similar problems. 1 liter of crude oil weighs 9.6 Newton. So find the calculate the specific weights, density and specific gravity. Answer is also is given here. So note it down, find yourself, and we will discuss in the next class. Then next problem, calculate the density, specific weight and the weight of 1 liter of petrol, and the specific gravity S is equal to 0.7. So next we will move to the next topic is viscosity. The next fluid properties in the fluid mechanics, that is of viscosity. So from we are arranged as a high viscosity to low viscosity. So high viscosity is mercury, then second ethanol, then water, then tetrachloromethane, then benzene, then octane, then diethyl ether. So we are categorizing, we are arranging higher to lower viscosity. So what is meant by viscosity? So it is a property of liquid which provides resistance to flow. You know, suppose a drop of water which is flow, we are falling from the slopy area. The flow which is having a resistance to against the gravity. So that resistance we call as a viscosity. So if drop the water in the flowing nature, it comes fall down very quickly. Whereas if you drop a honey, honey, if you drop on the slopey area, it comes very slow in manner and touch the ground very little time later. So, so based upon the resistance, we can categorize as a higher viscosity to the lower viscosity. For example, flowability of honey is very poor as compared to milk. Honey is higher viscous. The viscosity of honey is much higher than milk. சரிங்களா? So another term we have to know that kinematic viscosity, nothing but viscosity divided by density. சரிங்களா? So I want to ask you one question regarding the viscosity, that is noted down. While coming to the next class, we will discuss why does the viscosity of a gas increases with the temperature while that of a liquid decreases with increase in the temperature. So they are asking in the viscosity nature, if it is heating something, why viscosity of for a gas is increased whereas a liquid decreases. Why? What is the reason? So discuss we discuss among yourself, and we will discuss in the next class for this question. So this is the basic definitions for your viscosity. That is a property of a fluid which offers resistance to the movement of one layer of fluid over another adjacent layer of the fluid. In case if one layer is moving to the one place to another place, another fluid is flowing on the above the layer. That is there is a property which offers resistance to one layer to another. That property we call it as the viscosity. So here the shear stress required to produce unit rate of shear strain, that is the finally the formula is for the viscosity SI unit. Note it down. For the SI unit, the viscosity is Newton second per meter square. For us MKS system, kgf second per meter square. For CGS system, dyne second per centimeter square, or also called pies. If viscosity is given in pies, so instead of they given in terms of Newton second per m square, if a viscosity is given in pies, it must be divided by 10 to get its equivalent numerical value in SI units. Sometimes a unit of viscosity as centipies is used, where 1 centipie is equal to 1 divided by 100 pies. The viscosity of water at 20 degrees Celsius is 0.01 pies or 1 centipies. So these are the technical term, technical units or technical value you have to know for the preparation for gate preparations. So that's why I highlighted the some of the points. So everything you have to note it down. So then only it will be easy to understand or easy to keep it in mind. So these are the this is the table which is showing the viscosity value for different fluids. So kindly note it down. Sometimes they will ask what is the viscosity for some specific fluid, that is alcohol or ethyl alcohol. So likewise they will ask sometimes in terms of Newton second per m square or centipies or some pies. Sometimes they ask it. So kindly note it down. So next one is kinematic viscosity, the ratio between dynamic viscosity and density of fluids. So this is the basic formula which is used in the kinematic viscosity. Unit is meter square per second in SI units, whereas CGS centimeter square per second, or Stoke. So Stoke, one Stoke, which is equal to 10 to the power minus 4 meter square per second. So kindly note it down. So Newton's law of viscosity, it states that shear stress on a fluid element layer is directly proportional to the rate of shear strain. So constant of proportionality is called coefficient of viscosity. So this is the formula which is used to finding the relation between shear stress and the viscosity. So tau is equal to mu into du by dy, where here tau is equal to shear stress, mu is viscosity, du by dy is the velocity gradient. So these are the basic problem which is frequently they will asking in a gate questions. A plate 0.025 mm distance from a fixed plate moves at 60 centimeter per second, requires a force of 2 Newton per unit area to maintain this speed. Determine the fluid viscosity between the plates. So, what are the data is given? Distance between the plates is given, that is dy is given. Then velocity of the upper plate is given, that is u is 60 centimeter per second. So converting in terms of 0 meter, so 0.6 meter per second. Then force F is equal to 2 Newton per second m square. So we already know that the relation between shear stress to the viscosity. So tau is equal to mu into du by dy. So du is change of velocity. So here only one velocity is given, that is 60 centimeter per second. So 60 0.6 meter per second minus 0. So simply put it the direct value. So change of distance is also 2.5 mm only, to 0.025 mm. So substitute the equation, then find the fluid viscosity. So it's a direct substitution. We are substituting the value in the respective unknown data, respective known data, and find out the unknown one viscosity. So finally, you will get the 8.33 into 10 to the power minus 4 pies. 8.33 10 to the power minus 4 pies. So another question which is frequently asking in gate exams, that is if velocity distribution over a plate is given by, so directly equation is given instead of the value is instead of value is given, they they will provide some equations. So from the equation you have to find the values, then substitute the by substituting the term in which u is the velocity in meter per second at a distance y meter. They determine the shear stress at the y is equal to 0, y is equal to 0.15 meter. So dynamic viscosity 8.63 pi. So here pi's value is given, viscosity value is given, equation is given. So what is the shear stress at y equal to 0, y equal to 0.15? So simply that substitute that u we have to differentiate with respect to distance. You will get the du by dy. So velocity gradient. So 2 by 3 to the minus 2y. So substitute y equal to 0 in the du by dy equation. Then y equal to 0.15 in the du by dy equation. So we will get the value. So 0.667, 0.367. So substitute the equation, substitute the value in the equations. Tau is equal to mu into du by dy. So what is the shear stress at y equal to 0? The value is 0.5756 Newton per m square. Whereas shear stress at y equal to 0.15 meter, we will get the final value is 0.0, so 0.3167 Newton per m square. So let's take the example for your further preparations. Consider this assignment number 2 for your gate preparations. So kindly note it down, take a snapshot, screenshot, and solve it yourself. If you have any doubt, you can ask me for the next classes. The next fluid properties is compressibility, bulk modulus, surface tension, capillarity. So as the name indicates, compressible means we are giving a force to decrease the volume. So fluids which undergoes a change in volume or density when pressure is applied. So whereas incompressible fluid which does not show a change in volume or density when the pressure is applied. The mathematical representation as compressibility, which is equal to 1 by bulk modulus of elasticity. We mentioned as a K, small k. So bulk modulus of K is nothing but change in pressure divided by the volumetric strain. So dP by del V by V. So note it down the formula. Bulk modulus of elasticity K equal to dP by del V by V. So compressibility equal to 1 by K, vice versa. So let's see the problem related to compressibility. So determine the bulk modulus of elasticity of a liquid if the pressure of the liquid is increased from 70 Newton per centimeter square to 130 Newton per centimeter square. The volume of the liquid decreases by 0.15 percentage. So they're giving a pressure 70 Newton per centimeter square to the 130 Newton per centimeter square. How much volume is decreased? By 0.15 percentage is volume is decreased. So what is the formula for finding the bulk modulus? dP by del V by V. Here dP is change of pressure. So initial pressure is 70, final pressure is 130. So difference is 60. So 60. Here the mentioned as a volume decreases 0.15 percentage. So our change of percentage is 0.15. Divided by original volume is considering 100. So 0.15 divided by 100. So bringing to the numerator 60 into 100 over 0.15, which is equal to 4 into 10 to the power 4 Newton per centimeter square. 4 into 10 to the power 4 Newton per centimeter square, which is the value, which is the answer for bulk modulus. So next surface tension. Surface tension is nothing but there is a tensile force which is acting on a surface of the liquid by colliding with the one fluid particle to the another fluid particles. So that's why the insects, some other birds are standing on your fluids. So due to that nature, the tension of the surface film of a liquid caused by the attraction of your particles in the surface layer by the bulk of liquid, which tends to minimize surface area. Unit is Newton per meter. So in technical data, we can show that intermolecular attractive forces in the plane of the surface resulting downward net force and minimized surface area. So let's consider here this. Let's see the example. See the figure here. One insect standing on the water. So that water is leg is floating on the water only. So because of surface tension is caused by cohesive hydrogen bonding resisting an object trying to penetrate the surface of the liquid water. So let's see the problem for surface tension. Let it to get a question. Find the surface tension in a soap bubble of 40 mm diameter when the inside pressure of 2.5 Newton per m square above the atmospheric pressure. So what are the data is given? Diameter of the bubble d equal to 40 mm, convert in terms of meter, 40 into 10 to the power of 3 minus 3. Pressure in excess of outside is P equal to 2.5 Newton per m square. For a soap bubble, we know that P equal to 8 sigma by d. So this is the formula which is have to be keep it in mind. P equal to 8 sigma by D. So now substitute the value P as 2.5, D is 40 mm. So sigma value is 0.015125 Newton per meter. That is the surface tension. 0.0125 Newton per meter. So this is the problem which you can export from the surface tension. So another example, same, but so here droplet of water. That is a here different term is, so previous soap bubble. So 8 sigma by D. Here water droplet. Here considering 4 sigma by D. 4 sigma by D. So what is meant by capillary rise and capillary fall? We're considering a tube which is a water full of water in the any vessels. We are inserting a glass tube, and in the water level is increasing in the glass tube. That rise we call as a capillary rise due to the action of capillarity. Whereas if same glass tube which is inserting into the mercury filled vessel, the capillary fall will be happen in the glass tube. So how much rise is happen? We call it as a capillary rise. How much fall will be happen in the mercury? We call it as a capillary fall. So we have two formulas which is for using for capillary rise for the water, capillary rise for the fall for the mercury. Where here we are angle is considering for the water is 0 degree, so note it down. For us mercury we considering is 130 degree. So formula is H equal to 4 sigma by rho into G into D. That is for formula for the capillary rise. Whereas mercury H equal to 4 sigma cos theta by rho G D. So 4 sigma is surface tension, cos theta is your angle of inclination, rho is the density of water, G is the rho is the density of the fluid, G is the acceleration due to gravity, D is the diameter of the glass tube. So if it is negative sign indicates the capillary depression. So let's these are the two problem which is for your assignment for your gate preparations. We will discuss in the next classes. So this is the picture which is showing the capillarity. The blue color indicates the del H, that is the capillary rise from the vessels positive, whereas mercury the negative sign which is the downward direction, which is when inserting the glass tube into the mercury chamber, the mercury in the glass tube which will be fall the level difference between the chamber. That blue indicates water, red indicates mercury. So for this session, we will discuss about what is meant by fluids, what is meant by fluid mechanics, what are the classification of fluid mechanics. Then we'll discuss about what are the properties which is importance in the fluids, properties of fluids, that is density, weight density, specific volume, viscosity, kinematic viscosity, then capillarity, capillary rise, capillary fall, vapor pressure, phase tension, then compressibility. So these are the properties which we are discussing in this session. So I hope everyone will be able to understand what are the basics in fluids, what are the fluid classifications, what are the fluid properties. So everything we discussed in this session, I hope everyone will be able to understand all the concepts. So likewise, what are the problem which is given to assignment, kindly complete yourself, and if you have any doubt you can contact me or we will discuss in the further classes. So thank you to everyone. So we will see on the next preparation under the scheme of AICTE PRERANA, which is useful for gate preparation for SC students. So once again, thank you to everyone.